Hi, so in this video I want to talk about the itertools module. A lot of the code that we write when we're writing programs has to do with iteration, right? Loops basically, and repeating things. Now, as I showed you in a previous video, using indexing for iterating over sequence types is generally, but not always of course, not considered Pythonic. And I've got a lot of detail in that previous video on that. Now, in addition to all that, we also have the itertools module, which provides us with a wealth of additional functions to help perform operations involving iteration. As Pythonic developers, you really need to get to know this module really well, and we can use it to our advantage. So I would urge you to read the docs on this module. They're very well written, they're concise, and the module itself doesn't contain hundreds of functions. It contains a few, but they're really, really useful. So I've got the link in the notebook. The link for the notebook is below. It's in GitHub. Go ahead and access it there. Basically, it's the Python's official documentation for itertools. So let's explore a few of those functions. The first two we're going to look at are map and starmap. So let's go ahead and see what it does. So let's look at the map function first. The map function is used to apply a transformation to the elements of an iterable. And very often that's what happens when we're dealing with iteration. We're essentially transforming one iterable into another iterable. Or maybe we're summarizing an iterable. But very often we're just doing a transformation. So let's go ahead and see 1, 2, 3, 4, 5 again. And then I'm going to create this function called square, which is kind of a silly function, but it will serve to illustrate the point here. And all that's going to do, it's going to take a value x and it's going to return that value squared. Now we can generate a new list consisting of the square function applied to each of the elements of the list. So we're transforming the list L by applying square to each element of L. So of course we could use a loop to do that. We could also use a comprehension, but here I'm going to focus on map. And I will show you how that works. So what we want to do is we want to calculate a new list called the results. And it's going to be the map of taking the square function applied to each element of this iterable. L doesn't need to be a sequence, just needs to be an iterable. And the results now is going to be itself an iterator. So again, this is a theme that's very common in Python 3. A lot of these functions don't actually calculate the values until you request them, and then they calculate them one by one. So we're not incurring the cost of calculating all the squares right away. Neither are we incurring the cost of storing the squares as a list or as a collection somewhere, right, in memory. It's not using memory for that, and it hasn't done the calculations yet. However, it's an iterator, so we can iterate over that iterator. So for result in results, let's just go ahead and print the result. That's it. And so we get 149, 16, 25. Now we could easily achieve a similar thing using a list comprehension, right? We could do something like this. We could say square x for x in L. That's fine. We've created this list. But of course, the one drawback here is that, well, we've created a list and we've incurred the initial upfront cost of calculating everything. If a person using this in your code, if you only use, let's say, the first two elements, then you've stored those three elements for nothing, and you've calculated those three elements for nothing. So instead, you might use what's called a generator expression, which is very similar to a list comprehension. It's essentially a comprehension syntax, but it generates, or it creates, a generator function. So if we look at results, we have a generator object. But it works the same way as the one that we got back from map. We can just basically iterate over that. So we could say for result in results, print results, like so. And so we get 149, 16, 25. So yes, using a generator expression works just fine, and it is Pythonic. But many people prefer using map, right? Because if you take a look at the two side by side, let me copy paste that from the notebook. Let's just put them side by side to compare. You can see that this is actually more expressive than this. This is also very easy to understand. I'm not saying it's not, and that's fine too. But using map, to me personally, I like this because it's very, very explicit. It's very expressive. I'm applying square, which is a function, to every element of L. I don't have a for and in. I don't have the brackets here to actually make the function call. To me, it's a simpler thing, but we get the same thing. We get an iterator back, and it's lazy evaluation. So related to the map function is the starmap function, which is also located in the itertools module. So let's go ahead and import it. From itertools, import starmap. Now this is used when the function that you would use in a map requires more than one positional argument. Square, in our case, only required one positional argument, which came from L. Right? So it passed every element of L, single value, into square. What happens if the function you're calling needs, let's say, two values to be passed in? Well, map isn't going to help us unless we kind of start tweaking what this list looks like and so on. And then we have to be careful because, yes, it's a tuple. We could create a tuple of value, a list of tuples for arg1 and arg2. But square is expecting them as arguments, separate arguments, let's say. Well, not square, but your other function might be expecting two positional arguments. And passing a tuple isn't going to help. You would need to unpack the tuple, right? And this is actually exactly what starmap does. It unpacks the tuple that you're going to provide in your iterable before passing it to the function. So it's very, very straightforward. Let's go ahead and from math, I'm going to import the power function. So I'm going to import power. And for people that were around a long time ago, that might remind you of the Batman TV series, the animated series. But anyway, power of 2, 3 is taking 2 to the power of 3, right? So this function, POW, expects two arguments, two positional arguments. So let's say that we want to do this. Now, we're going to create our positional arguments by using tuples. So we're going to say 2, 0, then we're going to say 2, 1, and then I'm going to do 2, 2, and then 2, 3, and then 2, 4, and then 2, 5. Okay, so we could define them this way. The way that I would actually do it is I would use a list comprehension. So I'm going to say 2x for x in range 6. Much simpler to type than all these commas and brackets that are all interspersed. But you get exactly the same thing. If we look at the output of this, that's what we have. If you look at the output of that, you have exactly the same thing. So again, we could use a generator expression to do this, right? We could say results equals, and then let's do a generator expression. You could do a list comprehension, but that of course incurs the upfront calculation cost and the storage. So we could do that. We could basically iterate through L, unpack the positional arguments, and then pass them over here. That's one way of doing it. You'd get that. Got a typo, let me fix that. So this is a generator object, so let's go ahead and iterate through it. So we'll do that by passing it to the list. And you can see we get 1, 2, 4, 8, 16, 32. Another way to do it would be to do this. We could say, instead of unpacking here, we could say for element. So for let's call it args in L. And I'm going to unpack that before I pass it to the power function. And of course, I get the same result. Now we cannot use map, right? We cannot say results equals map POW to L because that's going to fail when we try and list it. Of course, this, remember, doesn't do the calculation right away. That's why we don't see any exception. But if I try and actually do the calculations, it's going to fail. And it's going to tell me that POW expected 2 arguments, but it only got 1. Yeah, it got past the tuple, 2, 0. That's not what it wants. You need to unpack this into the arguments. You need to do kind of this approach over here. And that's exactly what starmap does. Starmap does that. It basically unpacks whatever the tuple is in L and passes them as positional arguments to POW. So again, compare the two approaches side by side. You could, or maybe the 3 approaches, because we technically also have this one over here. Right? These are the 3 approaches. They're all fine. They're all relatively Pythonic, right? But this one more so in my mind, because this is very easy to read. Starmap, so it's going to explode all the, sub lists basically that are in L and then pass them as positional arguments to POW. So there's nothing wrong with the generator approach, but I think starmap is cleaner and it's more expressive. So the next function I want to look at in the itertools module is the chain function. The chain function, let's go ahead and import it. So from itertools, let's import chain. And this function is very useful for iterating across multiple iterables without having to create a temporary union of all the iterables. Let me show you an example. Let's say I've got this first list, 1, 2, 3, 4, 5. Let's say I've got another sequence, A, B, C, D. And let's say I've got another sequence, which is going to be a tuple, let's say 100, 200, 300. And what I want to do is I want to iterate over the elements of L1, L2, which are the characters A, B, C, D, and L3, one after the other. Now, we could do it by joining all the iterables together, but this is a list, this is a string, this is a tuple. So we can join them, but we're going to have to do a little bit of type conversion. So let's say combined L1 plus list of L2. So we're going to transform the string ABCD into a list of characters ABCD, and we can now concatenate those two lists. And then to that, we can concatenate L3 again, making it, turning it into a list object. So if we do that, then we have our combined iterable, which contains all these things. And now we can just say for EL in combined, and then we can say print EL, and then I'll do an end just equal to a space, let's say. And so we get that, right? We've essentially iterated through L1, then through the elements of L1, then the elements of L2, and then the elements of L3. So two things here though. We had to duplicate data, so more memory, right? And we had to write code to combine the iterables. It's much simpler to use the chain function. And again, chain is a lazy iterator. It is not going to create this memory overhead by combining all the iterables into a new one. It's basically just going to use the existing ones and then iterate over all the elements of the first one. And then when it's done, it's going to move on to the second iterable, iterate over all the elements of the second iterable. When it's done, third one, fourth one, etc. So let's go ahead and try it out. It's very simple. We're going to say for EL in chain L1, L2, L3. I don't have to worry about type conversions because I'm not combining anything, right? As long as L1, L2, and L3 are iterables, not just sequence types, any iterable, this will work. So then we can just say print, just like we had before, EL and equals that. And we get the same result, as you can see. Now the chain function actually also has a from iterable variant, which is very slight, and you would use it where instead of having separate iterables like we had with L1 and L2 and L3, we have a single iterable that contains iterables, and we want to loop over the elements of each of the iterable sub-elements. So here's an example that will make it very clear. Let's say I've got this list, and this list contains this list itself as the first element. So that's an iterable. I'm going to create a string here that is also an iterable. And I'm going to create a tuple, which is also an iterable, like so. Okay, so now my list essentially is a list of iterables. And of course, more generally, it could be an iterable of iterables, not just sequence types. So if we have that, then if we do for EL in chain, if we just chain what's in L, right? Let's go ahead and do that, print EL, and actually I'll print them on separate lines. You can see what it did. It actually just iterated through L. So it grabbed the first element. That's what came back first, printed that out. Then it grabbed the string ABC and so on. But that's not what I want. I want to iterate over the elements 1, 2, 3, then ABC, then 10, 20, 30. And so for that, we can use the from iterable variant of the chain function. So we would say for EL in chain from, this is kind of a little bit weird, but this is how they've done it. They've attached basically another function to the chain function. Since, functions are objects, you can, add any attribute you want. In this case, there's an attribute called from iterable, which happens to be another function, a callable. And we pass it L, right? So that's just the syntax thing with from iterable. And then we'll do the same thing. We're going to print EL, and then I'll do the end now equal to the space, so I keep it all on the same line. And you can see it did that, right? So if I put a comma so that you can see, right? We get 1, then 2, then 3, then A, then B, then C, and so on. So that's how the chain from iterable works. The next function I want to talk about in the itertools module is the islice function. So as you know, slicing is reserved for sequence types, right? Like lists and tuples and strings. Things that can be indexed, then we can use slicing. But we cannot use slicing for iterables in general, right? So what I mean by this, let's say that we have this expression, this generator expression. So I'm going to do EL times 2 for EL in range 5. So I'm just going to multiply every number from 0 to 4 times 2. Now, if I look at what data is, well, that's just a generator object, right? It is not actually a list. It's not a sequence type. It's an iterable, but it's not a sequence type. So if I try and do data 0, well, I can't access it that way. I cannot access, elements of an iterable or iterator in general by using indexing, because it's not a sequence type. I also cannot use a slice either. That's not going to work. If I want to go from 0 to 2, for example, that's not going to work either. So this is where the islice function comes in. It basically gives us something that's very close to slicing, but with general iterators. So from itertools, let's import islice, and let's go ahead and use it. So I'm going to say for EL in. So now I'm going to take a slice, right? So I slice, and I'm going to put in my generator expression right here, because I can only iterate through a generator once, right? So in general, you have to be careful with that when you're dealing with generators and iterators in more general terms. So I'm going to take this generator and I'm going to start at 0. That's the default, and end at 3. So this is like doing a slice 0, 3. So it's going to end at 3, which means it's going to be not inclusive of 3, right? It's going to stop at index number 2. So if I do that and I print the element, then you can see I've got a typo somewhere. So for EL in islice, I'm sure I got something messed up with my parentheses. So I probably should have broken that out into 2 lines. Maybe I should do that. Oh well, you can do that yourself. So you can see that, I got 0, 2, 4, which is what I would expect. Those were the first 3 elements of this generator here, because I took the numbers from 0 to 5 and I multiplied them by 2. So 0, then 2, then 4, etc. So that's what I get here, 0, 2, 4. And this islice also supports, so it supports just having an end number, which means it starts at the beginning and stops at that. So if you just want the first element, well, you would stop at, you would go up to 1 essentially, right? You would do this and you would just get the first element. But it also supports start, stop, and step, just like a slice does. However, it does not support negative slicing. But we could do this. We could say for EL in, and let me just make my generator separated here, just like so. So it's a little clearer. So for EL in islice, we'll take our generator and we're going to start at 1. We're not going to specify an end. So this is like leaving that empty value in a slice with, let's say, a list slicing, right? It'd be 1 colon and then just colon right away. And then we'll go in steps of 2. So we're saying go all the way to the end, but go in steps of 2. And let's go ahead and print the element. You can see now we get 2, 6, 10, 14, 18. By the way, if you want to see what the original was, you'd be able to do it this way, but then of course it's a generator, so you're going to have to redefine it before you use it, for a second round of iteration. And let's go ahead and print it. You can see this is the full thing, right? 0, 2, 4, 6, all the way up to 18. Here I started at 1, so it started at 2, and it went in steps of 2 all the way to the end as far as it could go. We could do this. We could say for EL in islice gen. Of course, I have to redefine gen because it's now exhausted. So let me copy paste. And for islice gen, I'm going to start at 1 and at 5, so not including 5, of course, and go in steps of 2. So now this is the start, stop, and step all defined as well. And we'll do that, right? And we get 2 and 6. Or I could specify none for the start, and then I'd get 0, 4, and 8, and so on. Now you can even slice sets, although since sets are not ordered in any particular way, I can't think of a reason to actually slice a set. But just to show you that this islice works for iterables in general, not just sequence types, let's go ahead and create a set. Let's say A, B, 10, and 3.2. Let's say I've got a set like this. Now I can go ahead and say for EL in islice, and we'll take the set S, we'll start at 0, or I could say none, it's the same thing. We'll start at 0 and end at, but not include 2. So we're looking for 2 elements basically from here, from the set. I have no idea what order it's going to come back in. As you can see, it gave me A and then 10. You know, your results may vary very well because there is no guarantee of order for sets. All right, so that's kind of what I'm going to cover on the itertools module. There are lots of other functions in there. One that you may want to look at is the T function. It can be useful when you want to be able to, you know, iterate through the same generator, through the same iterator multiple times without having to rebuild the iterator. In general, what you do is that you tend to make a list out of your iterator, and then you can iterate through that list multiple times. And that may actually be more efficient than using the T that's in the itertools module, but it is available there if you need it. And I don't know, there's also a bunch of other functions. I cover many of them in my deep dive course. I'm not going to get into more details here. I have a link in my notebook that points you to the documentation for in the Python docs for the itertools module. You really ought to read it, give it a good read, and see what's there, so that in the future you may be able to leverage it. Now, if you like the style of programming with, you know, these iterables and these iterative functions that we have, and doing islice and so on, then you might be interested in a third-party library called More itertools, which is basically now that one contains a ton of extra functions that are, you know, very similar to itertools, but they go well beyond what itertools provides. But it's a great library, and again, I have the link for it in the notebook that's linked below. But at the very least, get to know the itertools module to better, you know, to have a better chance of writing Pythonic code. So thanks for watching.